Hi, hello, welcome back to our channel SRINIVAS THALAKOKULA. Do like, share and subscribe to our channel. Today I given Eamcet timetable. Please share to your college groups and your friends and tell to your friends. In previous class, solids part 1 completed, solids part 1 introduction completed, and tables. JEE Mains and Eamcet tables are more important. These two tables are completed. Now types of unit cells and what is definition of a unit cell. Let's go into the topic. Space lattice or crystal lattice. A space lattice is an array of points showing how molecules or atoms or ions arranged at a different sites in three-dimensional space is called as space lattice or crystal lattice. Next, lattice point that represents a molecules or an atom or an ion in a space lattice is said to be lattice point. Unit cell. Now going to the topic unit cell and types of unit cell. Small portion of crystal lattice which can be used as representing units in three-dimensional manner to get entire crystal lattice. Unit cell are two types: primitive unit cell and centered unit cell. Centered unit cell contains one or more constant particles present at positions other than corners. In addition to those corners. Next, body centered. In centered unit cell, body centered unit cell and face centered unit cell, end centered unit cell. What is meant by body centered unit cell? Body center plus corner. What is meant by face centered unit cell? Face center plus corner. What is meant by end centered unit cell? Any two opposite faces plus corner is called as end centered unit cell. These are three types of unit cell. In unit cell, primitive unit cell and centered unit cell. Next, Bravais lattice, 14 arrangement, 14 different positions, kinds of three-dimensional lattice. For example, if unit lattice is having cubical structure, the crystal is also a cube. Having a cubical structure, it is also a cube. These 14 Bravais lattice are grouped into the 7 crystal structures based on the unit cell symmetry. These 7 crystal types are 1, 2, 3, 4, 5, 6, 7. These are crystal types. Number of Bravais lattice. Next, common name of these lattice. Cubic 3. Number of Bravais lattice is 3. And common name is simple cubic, face centered cubic and base centered cubic. Next, tetragonal 2. Number of Bravais lattice is 2. Primitive, body centered and tetragonal prism. Next, rhombic 4. Number of Bravais lattice is 4. Primitive, body centered, face centered and end centered. Hexagonal 1. Bravais lattice is number of Bravais lattice 1. Primitive hexagonal prism. Next, tetragonal 1. Number of Bravais lattice 1. Rhombic heterogonal or primitive. Next, monoclinic 2 Bravais lattice and primitive and end centered. Tricline 1 number of Bravais lattice and primitive. Tricline primitive. Next, this is cubic in these 7, which is most symmetric cubic, and non-symmetric is triclinic and symmetric is cubic. Yeah, this is the crystal system, 7 crystal system. Next, the crystal structures depends on the set of the crystallography parameters. Yeah, this is the crystallography parameter systems. The systems: cubic, tetragonal, ortho, rhombic, hexagonal, trigonal or rhombic, heterogonal, monoclinic and triclinic. These are systems. Next, axial angular characteristics. Examples of common substances, symmetric elements possible. First start with cubic angular characteristics. A is equals to B is equals to C. A is equals to beta, gamma is equals to 90. A is equals to beta, gamma is equals to 90. Next, examples of a common substance: NaCl, diamond, PP, Hg, Ag and so on. Next, symmetric elements possibles: 4 3-fold axial, 6 2-fold axis. Next, tetragonal. A is equals to B is not equals to C. B is not equals to C. A is equals to beta is equals to gamma is equals to 90. Examples: SnO2, tin O2, TiO2, white SN, NiSO4, K4, FeCN, taken 6. Next, symmetric elements possible: 1-4-fold axis. Next, orthorhombic or rhombic. A is not equals to B is not equals to C. A is equals to beta is equals to gamma is equals to 90. KNO3, MgSO4, 7H2O, alpha S, K2SO4, BaSO4, PbCO3. 3 2-fold axis, 2-folded axis, 2 perpendicular planes. Next, hexagonal. A is equals to B is not equals to C. A is equals to beta is equals to 90. Gamma is equals to 120. Graphite, His, quartz, Mg, Zn, zinc, Hgs, Pbi2. 1 3-fold axis. Next, trigonal or rhombic hedral. A is equals to B is equals to C. A is equals to beta is equals to gamma is not equals to 90. SB, AS, BI, KMNO4, NaNO3, calcite. 1 3-folded axis, monoclinic. A is not equals to B is not equals to C. A is equals to gamma is equals to 90. Beta is not equals to 90. Next, monoclinic. S, CaSO4, Na2SO4, H10H2O, NaHCO3, FeSO4, 7H2O. 1-2-fold axis, 1 plane. Next, triclinic. A not equals to B, A not equals to B, B not equals to C, A not equals to beta, beta not equals to gamma and gamma not equals to 90. These are examples of a common substances: Cu, SO4, 5H2O, K2, Cr2O4, H3BO3. Next, there is no symmetrical element possible in the triclinic. Okay. Calculation of the contribution of the lattice point per unit cell of a substances. Unit cell and contribution of atoms per unit cell are 3: corners 1/8 and face centered 1/2, body centered 1. Net number of constituent particles. Yeah, here it is. Simple cubic unit cell. Corners 8. Simple cubic unit cell 8 into 1/8. 8 into 1/8 is equals to 1. Contribution of atoms per unit cell. This is number of atoms and number of corners. Face centered 0 and body centered 0. Net number of constituent particle is equals to 1. Face centered unit cell 8. Number of atoms 8 into 1/8 is equals to 1. Next, 6 face centered 6 into 1/2. Face centered 1/2 is equals to 3. There is no body centered and net number of constituent particles is equals to 4. Body centered unit cell 8. number of atoms 8 into 1 by 8 is equals to 1. There is no face centered and body centered. 1 into 1 is equals to 1. Next net number of constant particles is equals to 2. End centered unit cell 8 into 1 by 8 is equals to 1. 2 into 2 is equals to number of atoms into 1 by 2. Face centered is equals to 1. There is no body centered and number of constant particle is equals to 2. Then we completed this distinction between the crystal lattice and phase, different types of solids and different type of unit cells and Bravais lattice, and these are completed. Calculation of the contribution of this lattice point per unit cell is also completed, and voids and magnetic properties are remaining. So please like, share and subscribe to our channel, or you understand, like.